Hi, this is Shiv Kumar here, and today I am going to teach here probability. Before moving to that, I will tell you about myself. My qualification is Master of Engineering in Thermal Science, and my area of interest is mathematics. So every time they are asking 2 to 3 questions from probability. Let's start that probability here. You see, the probability of an event is defined as favorable outcomes by sample space. And here I indicated the favorable outcomes is M and the sample space is N. So here M could be and equal to N. M means M is less than and equal to N. Correct. So if I'll say here like a coin is there, unbiased coin. Unbiased coin means there will be one side head and one side tail. But if you assume that a biased coin means it will be both side head or both side tail. Correct. So I can say that if I'll tell you like a biased coin, what is the probability of getting a head? What is the probability of getting a head? So we can say that the sample space is 2 and the outcomes will be also 2 here because both the side is head. So 2 that is equal to 1. So probability of any event, it could be equal to 1 also. But if you take an unbiased coin means one side is head is there, another side tail is there. Correct. So if I take a sample space, the sample space will be either head or tail. If you toss the coin, it will come head or tail. But if I wanted to find out the relative probability of getting head, it will be 1 by 2 because the favorable outcomes is only one times out of 2 times. It's a 1 by 2. So I can say that the probability of any event, it could be equal to and less than n, where n I assume that it's a sample space and m is here favorable outcomes. So here the next thing is probability of any event that could be greater than or equal to 0 but less than or equal to 1. That is possibility is there. Here we saw that possibility. So first of all we will discuss that sample space of all types of event. So first we took that here unbiased coin. And if you toss an unbiased coin n number of times, the sample space will be 2 raised to n. Because 2 indicates that one side is head is there, other side is tail is there. Correct. So it's a 2 raised to n. Similarly, if you take it here n is equal to 1, then you will get the head and tail. That is the sample space. But if you toss n is equal to 2 times, like if you toss coin 2 times, see first time it could be head, second time also it could be head. First time head, second time tail, or first time tail, second time head, or both the time it could be tail only. Correct. So the favorable here sample space, I can say that it's a 4, or else you can find out 2 raised to 2, it's a sample space. Same way n is equal to 4, if you toss it here, the 2 raised to 4 means it's a 16. It's a 16. So there will be a 16 sample space. So you remember that if you are tossing an unbiased coin, then the sample space will be 2 raised to n. Similarly, if you are rolling a die n number of times, so it will be 6 raised to n. But in dice, there is a number from 1 to 6. So that's why we are saying that 6 raised to n. So n is equal to 1 means that can come up any of the number like 1, 2, 3, 4, 5, 6. But if you toss it, n is equal to 2 times, it's a 6 square, 36. 6 square, 36 means if you 2 times, if you are rolling 2 times, first time it can come up 1. Second time also it can come 1. Your first time 1, second time 2. Your first time 1, third time 3. So it can go up to 1 to 6. Or else first time 1, 2, second time 1. Your first time 2, second time 2. So it can go up to 2 to 6. So similarly, you have to go from 6 to 1 to 6 to 2, 6 to 6. And in total, I can say that there will be 36 sample space. So this is for rolling a die n number of times. So that one you keep in mind that 6 to power n. So here, like if I'm tossing a coin, tossing a coin 3 times. So if I tell you what is the favorable outcomes of getting head exactly 1 times, what is the favorable outcomes of getting head exactly 1 times? To see 1 time head and 2 times it should be tail. That is my favorable outcomes. It should be 1 time head and 2 times tail. So see this letter, how many ways we can arrange it? 3 factorial divided by head is 1 time, tail is 2 times. So divide by 2 times. Divide by 1 factorial into 2 factorial. And this one we can write down as a 3C1. So that combination comes from here. That is from arrangement only. Correct. So here, if I am tossing a coin 4 times, correct. So if I tell you what is the probability of getting 2 head, So first of all, you need to find out favorable outcomes. Correct. So there should be a 2 head. Out of 4 times. So that head and tail. 2 times head and 2 times tail. So this letter we can arrange it by how many ways? 4 factorial divided by 2 factorial into 2 factorial. And this one we can write down as a 4C2. So we can apply directly combination in probability. Correct. In a case of dice also, if you are rolling a dice 6 times, then what is the probability of getting a number 6 times 6? 6 times 6. So we can apply the combination property there also. Correct. So the sample space for coin case and dice case, we saw that here. Now come for the sample space for card. So there is a total 52 cards are there. In that there will be 2 colors, black and red. Again the black will be 26, red will be 26. Again the black is divided into 2 types, spade and club. Spade will be 13, club will be also 13. And the red is divided into again 2 types, heart and diamond. So heart and diamond will be respectively 13 and 13. Correct. So you have a 13 cards. That is starts from A to K. And each card is 4, 4. So I can say that 13 into 4 is